Differential equations, we are wrapping up lesson 1.3, dealing with a mixture problem. Remember, in this section, we are being given real-world situations that can be modeled and represented with differential equations. So let's just read this together. Suppose a large mixing tank holds 300 gallons of brine. That's water with a certain number of pounds of dissolved salt. And another brine solution is pumped into the tank at 3 gallons per minute. So that's very important information that we have right here. The concentration of salt in this inflow is 2 pounds per gallon. When the solution is well stirred, it is pumped out at the same rate as entering, so it's going to be 3 gallons per minute. If A of t, and this is so critical right here, if A of t denotes the amount of salt in pounds in the tank at time t, then the rate at which A of t changes is a net rate. So this is the critical point that we have right here. The amount of salt in pounds, when we're looking at that rate changing with respect to time, honestly, it's the amount, it's the rate of salt coming in minus the rate of salt coming out in pounds per minute for both of these. So that's the whole big picture of a mixture problem. It's rate in minus rate out. So let's just break this down a little bit and see if we can, get this to make some sense. Just consider the rate coming in. Well, we were told that the rate coming in, we have this brine solution, it's pumped in at 3 gallons per minute. However, this concentration of salt is 2 pounds per gallon. So the reason why they gave that to you is so that we could cancel out the gallons and see that the rate in is 6 pounds of salt coming in per minute. So yes, this salt is dissolved and it's well mixed in, but really, if we just looked at the salt, imagine that we could not see the liquid. If we just saw the salt coming in, it would be 6 pounds per minute. And the reason why that's so important is that's really what dA dt is going to really be representing. It's just the salt in pounds changing with respect to time. Here's where we have to break it down a little bit more. The rate coming out. Well, we know that it's pumped out at the same rate as entering, so we're still going to have 3 gallons per minute. But the big question is, just as we came up over here where we had pounds per gallon, we'd like to have pounds per gallon just as well, so that we can wind up with pounds per minute. So the big question is, how many pounds of salt are we going to have right now? So, A of t, remember, in green right here is the total amount of the liquid, and A of t, imagine that we just saw that salt. It was that amount of salt per gallon, per 300 gallons in that tank, if we were to look at that rate. And we could say A of t pounds per that 300 gallon. So that's the rate of the pounds of salt per gallon that we have exiting. Remember, that's really what's coming out. So what's going to happen is these gallons are going to cancel, and the 3 goes into 300, and you'll be left with 100. What are we left with? Well, A over 100, and that would be pounds per minute. So what we're going to see is dA dt, like we just said earlier, is rate in minus rate out. It's simply going to be 6 minus A all over 100. And then we are done.